Point 4, we're going to discuss subsets of lines and planes. Let's go over a few definitions, and let's take a look at our illustration. In the upper right-hand corner, we have line K, and on line K is point D, A, B, and C. Our first definition is half-line. A half-line is a subset of a plane consisting of all the points on a given side of a point on the line. Let's take a look at point A. All the points on the right side of the line are point B and C. The points on the left side of point A on the line is point D. Half-line AB is denoted using an arrow to the right and an open circle with the end point A to the left, and that's where we begin, and B to the right. Similarly, we have the ray. Now the ray is the union of a half-line in its origin. Ray AB is denoted point A and point B with an arrow over the top going to the right, but this one has, I'm sorry, I just cannot draw a circle with this program. This has a closed circle over the A. Just to make a note, the ray will always be written to the right, and the half-line has the option to go either direction, but I suggest you make your half-lines travel to the right just for some consistency. We have opposite rays. We have ray AB and AD. They share the endpoint A and are opposite rays only if A is in between points B and D. The segment. A segment is 2 points and all the points between them. So as an example, we have segment D and we have segment C. All the points in between D and C are part of the segment. In this instance, you see A and B designated. So A and B are between D and C, and they are all part of the segment DC. Looking at the same line, line K, with points D, A, B, and C on the line, let's look at a ray. We're going to look at ray AB, and ray AB has endpoint A. It travels to the right, and you can see with the arrow that the arrow begins over the endpoint A, and the arrow moves to the right. AB equals ray AC. So ray AB equals ray AC because when we're doing these points, when we're designating the points of the ray, AC travels in this direction, but AB also travels in this direction and technically goes on indefinitely. So they're actually the same rays. Half-lines. Half-line AB is also equal to half-line AC because they both name all the points on a given side of a line. So once again, you have your endpoint A, and half-line AC travels to the right indefinitely, and so does half-line AB. They are the same set of points. Segments are named using the 2 endpoints of the segment. As some examples, I named DA, DB, DC, AB, AC, and BC. You can also name the segments in the opposite direction, but it's not necessary to name them both for the same answer because BC and CB are the same set of points. When naming a half-line array, the origin or endpoint is named first. The second letter identifies the side of the line or the direction. So AB and AC named the same, ray AB and ray AC named the same set of points. We also have another definition that we've learned previously, and that's the definition of betweenness. Point B is between points D and C. We denote this by writing D-B-C. For this to be true, D, B, and C must be collinear, and ray BD will intersect ray BC at point B. So BD will intersect BC at point B. Point E is not between D and C because B, DB, and C are not collinear, and that visually you can see that point E is not between them. The line separation postulate, postulate 1.4, every point on a line divides the object into 3 disjoint sets. Those sets are the 2 half lines and a point. Point A separates, looking at the line, point A separates line K into 3 disjoint subsets, point A, or the point itself, half line AB, and half line AD. The open circle above A, the origin of each half line, indicates that point A is not included in the half line. Because a ray is a union of a half line and its origin or its endpoint, the circle is closed and the point is included in the ray. I know I've said that more than once, but it's very important to remember. Let's look at example 1. Using the same line, show that C is not between B and D. Now we just looked at an example of where we had a point that was between 2 other points. We're trying to show that a point is not. Now looking at the line, you can see that C is over to the right of the points D and B. It's not in between. In fact, it's point A that is in between D and B. So how do we show that? Well, though D, B, and C are collinear, ray CB in intersection with ray CD equals the ray CD, not point C. So before, when we were doing the point in between, the answer was the actual end point in between the rays. This time, we are looking at an actual ray as the answer. Why would that ray, the answer be ray CD? Because if you remember, the points on ray CB and the points on ray CD are the same set of points. So I just named the longest set of points that's denoted. Let's look at example 2. Determine whether each statement is true or false. We're using the same line. So, line BC in intersection with ray BC in intersection with half line BD equals point B. Is this true or false? Well, BC has a closed point and it travels to the right, And BD has an open point and travels to the left. They are not in union. They are not two rays. One is a half line, so this is false. Though point B is an element of ray BC, BD is not an element of half line BD, so it creates an empty set. Answer B. Ray BC in union with half line BD equals the line CD. This is actually true. So ray BC has its endpoint at B. It's in union with BD. And it combines with the points to its left to form a whole line. Let's look at the last one, C. Ray DA in intersection with ray CB equals segment CD. So DA and ray CB. CB actually crosses back over DA, if you note. That gives us the segment CD. Now, why would that be a segment and not a line? Because we're naming two different endpoints. We have endpoint D and we have endpoint C, and that is where the line begins. It is not a continuous line on both sides.